Okay, and let's continue on to section 1, Introduction to Application-Centric Infrastructure, Policy-Driven Architectures. In policy-driven architectures, we're going to see the difference from what we know about networking and segmentation versus what ACI offers us. Okay, so I already took the liberty of designing an ACI tenant. So the first thing we have is a EPG or endpoint group. The endpoint group is called Web A. If you know in a traditional environment, chances are all the servers are going to be on the same VLAN. They're not going to be on different VLANs. You usually have a single server VLAN and all the servers are sitting on the same VLAN. So that already makes the issue a little bit complicated when it comes to segmentation between servers, because we know that we can segment servers to clients, but what about segmenting servers to servers, right? So in this scenario, you might say, but why I need to segment servers to servers? Well, one thing is, if you suffer a breach or an attack, you might stop the attack from spreading to other segments or other resources on your network, right? So let's say the web server needs to communicate to the app server, and the app server needs to communicate to the database server. The web server might not need to communicate to the database server at all. So why allow that to happen? Well, let's draw it in the traditional way. So in the traditional way, we usually, let's say we do have separate VLANs. And again, I know that most environments, they are just using one flat server VLAN, and all the servers are basically on the same IP address space. So let's say we got the web VLAN. Right? We got the app VLAN and we got the database VLAN. In order for us to isolate those three segments or those three subnets or those three networks, we need to put a firewall, or we need to put some sort of ACL on the core switch where this inner VLAN routing is happening, right? And we know that putting ACLs can become quite a nightmare. So that's why I would not suggest you try to isolate unless it's a very, very, very static network. If your network constantly changes, you keep adding, keep expanding, it's not a good approach. So we have a firewall, and then we have policies for different zones. So let's say this is web zone, this is the application zone, and this is the database zone. And I allow the traffic, the source to my destination via a stateful firewall, and the firewall will either allow it or block. Okay. So problem in this scenario, or the problem in this design, is that you cannot scale, meaning that your data center cannot grow. And why? You only have a firewall. You cannot add multiple firewalls, because in a traditional architecture, the network is pretty much static from a layer 3 routing standpoint. You cannot just route and keep adding layer 3, because as we mentioned before, it's usually a single core or a single point of routing. So we have a traditional network. We got a core, we got a distribution layer, and we got a firewall. Let's say we isolated the network, right? So I got some servers connected here, and this is my app. This is my database, for example, and my firewall is here, and then the core switch is here. In order for me to communicate those VLANs together, I got to pass via the firewall from my source zone to my destination zone, and I should have a policy here that will allow or deny that traffic. And as you keep adding policies, it's just going to become a nightmare to just even scroll and try to find something there, or try to troubleshoot a specific policy because you're having some sort of an issue. Yeah, firewalls and segmenting servers themselves is quite a nightmare. In the traditional architecture, it's not even a good approach. That's why you usually end up with a single server VLAN, or one or two server VLANs, but basically all my servers are on the same IP space, so they can communicate without going to the core. So they are exchanging information. And let me go ahead and delete real quick. I'm going to erase. Problem with that is you have a server here, and this is the same VLAN. And this is server 1, this is server 2, and this is server 3. And let's say server 1 gets compromised with ransomware, and it turns out because I am at layer 2, it spreads to server 2, it spreads to server 3, and they don't actually go through a firewall to allow or deny a specific traffic. Okay, in ACI, we mentioned we have endpoint groups. So we separate servers into endpoint groups. We classify the servers and we give them a profile. So we basically profile the servers themselves into an endpoint group, and you can refer the endpoint group as a VLAN. I try not to relate traditional to ACI because you're going to be confused sometimes. So try to see this as an endpoint group, not a VLAN. But again, it's technically a VLAN, but it does much more than just a VLAN itself. And you might think, well, my environment is not suitable to be changing to different IP schemes because I have my web and my app on the same IP space. So if I re-IP one of those, my application will break and I will need to reconfigure all over again. I got to go into my configs and change or update the IP. That's not a possibility. So in ACI, let me tell you, there is a cool way of segmenting, and this is the UEPG, or you can do microsegmentation, in which I can grab an IP or a server on the same VLAN and completely isolate it from the other servers on the same VLAN. And that's cool, right? Yes, you can actually segment an IP or a server that is sitting on the same VLAN and not allowed to communicate in or out to other servers on the same layer 2. That's cool. Okay, so I'm going to show you a section where we're going to configure microsegmentation and you're going to see this power. So we mentioned we got the web and we got the app and we got the database. The information that the web needs to parse out to the customer, right? So the customer logs into the web server or the website to access the account services app or one of the account services application. And this is called application A. In ACI, you classify under the tenancy application profiles. So based on your applications, if you have finance, if you have accounting, if you have CRM, if you have any type of application, then you create application profiles for each one. So let's say the web needs to query some data that the end user wants to filter, wants to extract. The application connects to the web server, or the web server connects to the application to obtain that information over a random port. And let's say it's port 51010. I'm just making an arbitrary number. Okay, so in a traditional network, this communicates over all ports. In ACI, I built a contract and I only allow inbound access over port 51010 or 51010. And I can say TCP or UDP, right? So I can actually police what traffic can the web server hit on the application, or what traffic can the web server access over a specific port on the application side. Everything else, I can block it. So let's say this web server gets compromised from an external user, somehow gets into the server, or there's a vulnerability in 443 and God knows, or the 80. And I am able to inject malicious payload, in this case ransomware, because I am actually completely isolated with a contract. And again, we're going to discuss endpoint groups, contracts, filters, subjects, etc. I can actually allow 51010 and block everything else. And if ransomware is using SMB, it's going to be stopped. Yes, because I am only allowing 51010. You see how cool that is? That is very cool. The application server, does it need to communicate to the database server over all ports, or do I have a specific SQL service that I need to access and everything else should be denied? I can actually do that. I can put a contract and only allow SQL services from the application endpoint group to the database endpoint group. So all my application servers are going to be able to talk to my database servers only in the port that I specify. And in this case, I can allow SQL. So you see the difference? I can isolate even to the lowest level, which is microsegmentation. I can grab, and let me go ahead and do another scenario where microsegmentation comes into play. Okay, so now that I clean our slides so we can do a demonstration on microsegmentation, we're going to do a quick demonstration on how this is giving you power that you always wanted when it comes to segmenting and protecting all your servers, or the crown jewels. So in microsegmentation, I can grab a let's say all my servers are on the 172.16.1.0/24. I'm just going to make a number there. We're going to say server 1, it's .1, server 2, you know what, .10, because usually .1 is our gateway. Most of the cases, not everywhere. I'm just going to make it a little bit more simple for you to understand. .30 and .40. So we got all those servers, right? With microsegmentation, if this is a database server, I can grab this and assign a UEPG, and I can completely isolate this machine to talk to the other machines over a particular port, and vice versa. I can have a contract that only allows specific connectivity between the other machines to my database machine. So I am only allowing from my clients or my consumers, and again, I'm going to discuss provider and consumers. This is the enforcement, or I would say the way that you enforce the policies, the contracts. They're sent from a customer to a provider. So in this case, I have a contract, and the contract is allowing the .30, .20 going to .10 over port SQL. They're on the same VLAN, but they are not allowed to communicate themselves because I just grabbed this endpoint and assigned to the microsegmentation endpoint group, or UEPG. 40, if I don't attach the contract that allows communication from the outside to the .10 using the database as the destination port, .40 is not going to be able to talk to. So this is the power. Don't worry, this is just a high level. I just want to show you how powerful ACI is. And I'm going to ask you now, how do you do this in a traditional architecture? Yeah, let me know. And we have here the big picture. I want to show you the big picture in ACI. And don't worry, I know that we're just starting, but I want to get you familiar with what are you going to be working with in ACI. So we mentioned in ACI, we classify everything with endpoint groups. This is where traffic is going to be local on your data center. Let's say our ACI fabric is in a data center. All the traffic that is locally adjacent, all my devices are on the same location, you classify them in endpoint groups, and then you can apply contracts to allow or deny traffic. And let's say I actually grab this to be a company because I am running cloud services and I'm providing services to Pepsi and Coca-Cola. And this is an example that's kind of odd that you're running both customers on the same fabric. But again, because they're on separate tenants, they're not going to be able to talk to each other. They're just going to talk inside their same tenant, unless I build a contract interface. And again, we're going to discuss that in another section. So let's say we have customers in Asia Pacific. We have an L3 out, and L3 outs are external domains, or I would say external networks that we connect into ACI. And we also apply a contract to it to allow the specific destination traffic that we want to. So let's say our customers from the US are allowed 80 and 443 to the web EPG because that's what they need to access. So why allow them to access absolutely everything on the server farm? No, we only want them to allow 80 and 443 only to this particular segment. We don't want Corporation 2 to access the Sprite application profile. We want Corporation 2 to only access the FANA profile or the FANA application. And you see, you can granularly segment your network to a point that you have full control of absolutely everything. It's not allowed to hit Gatorade, nor 7-Up. It's only allowed to hit Fanta because they're basically a partner of Coca-Cola. And Corp 1 is only allowed to work with Sprite because it's also part of Coca-Cola, but it's not allowed to talk to Fanta. And you can go very, very granular with a couple of clicks. Obviously, there's a lot of underlaying or a lot of effort that you got to put in place when you first build the architecture to make this happen. Let's say you have an internal segment, or I would say an internal VLAN for your support team. And your support team, their endpoints or the client machines are on the subnet. We are going to attach a contract to allow them to talk to the application side or the application servers over a specific port that we designate, because we don't want the staff to do RDP. We don't want the staff to open file shares on this box to communicate back down. No, we want to completely segment and only allow what they need to work with or what they're allowed to. Again, another layer 3 out. So if we have an external network that we want to interface, we can then connect our external networks, and this is a layer 3 out. And a layer 2 out is when we are connecting to a remote, or I would say a remote VLAN, but it's on the same network. It's not actually an external network. And when I mean external, either is connected over an IPsec tunnel, is connected over a MPLS circuit, is connected over a Metro E connection. It's just a layer 2 extension, or in this case, a layer 2 interface on the same network that I need to allow traffic into a particular ACI endpoint group. So this is a high level, and don't worry, when you finish this course, you're going to be very familiar with this, and you should be able to maintain, implement, and support a policy-driven architecture with ACI. Okay, everyone, and we got to the end of section 1. In section 2, we're going to bring the ACI fabric to life. Alrighty, we're going to continue with section 2. Let's bring the ACI fabric to life.